Welcome back to the final video in the series on producing a wind sound effect for Unity. In this video, we'll add the plugin into the project, we'll expose the variables, create a simple UI, add the C# script to control wind speed, and show you how it works. So onto the coding. First of all, you'll need to delete the old plugin from the assets plugins folder. If you do that, you should also remove the reference to it from the mixer. What you'll then have to do is restart Unity. Plugins are always loaded at the start when you load the project, so if you change the plugin it must be deleted and then Unity restarted, otherwise it will be the old instance. Then you can add the new plugin back into the mixer. If you click on the audio plugin in the audio mixer channel, you should see on the right hand side all of the variables that we created within the plugin. To expose a parameter that's in the plugin, if you right click on it, then you will see at the top and expose whatever variable that you've got. In this case, I've already exposed the wind speed and the distant resonance. You'll see the little arrows next to them. So I've done that, and then this is what you'll see. The exposed parameters will sit on the right hand side of the audio mixer, and you see we've got two exposed parameters. If you click on that, it will show you what parameters we've exposed. I've already renamed these parameters, but what you'll need to do is right click on each one and rename them. As you can see, there's a rename option. The name that you give this will be used as a string in the C# script, so it's important that you remember them exactly, as we'll be reusing these names. Next, we add a blank component, which I'm going to call wind, to the sample scene. In this case, I've already added a basic script, but what you'll need to do is to add a script in the inspector to this component. Then you need to open up the C# script. In the C# script, first you need to add using UnityEngine.audio. This will give us access to the audio mixer. Next, underneath, we'll create a public audio mixer, which I've called Master Mixer. When you open up the script in Unity in the inspector, you'll need to drag in your mixer into the exposed variable Master Mixer. Next, we'll add a high frequency wind component and a low frequency wind component. The high frequency wind component gives us short-term variation and makes the wind speed not static, so it's constantly changing a little bit depending on what's going on. And we'll also add a low frequency one, which is the gentle change of wind speed over a period. The way both of these work is there are four public floats. We have a mean amplitude and a standard deviation to the amplitude. So this is the speed, the amplitude of the speed. This will be a normal distribution again, so we need a mean and standard deviation. Also, we'll have a mean and standard deviation of the period, i.e. the length over which the wind speed changes. In the high frequency component, this will be very short, and in the low frequency component, this will be much longer, probably around about 10 seconds. Next, we have a couple of three private variables. One is the current speed, so that's the current wind speed, the current period, how long over which the change is occurring, and the delta wind speed. Now what we're doing here is we're storing what the current wind speed is that's been output, and how long over which this change is going to occur. And we'll actually decrement the current period, and when it gets to 0 or below 0, then we'll recalculate it with a new speed and a new period. And the delta is effectively the difference between where we were when we started and the target speed divided by the period. So it's the change over which the wind speed will change per second. Now this is replicated both as a high frequency component and a low frequency component. The only difference is that the means and the amplitudes will be different. On the low frequency component, the low frequency wind speed, the mean and the standard deviation are actually generated from the wind force, so the wind scale. Next we declare the variables for the gust. And this is similar again, where we'll have a mean and a standard deviation for the amplitude, a mean and the standard deviation for the period, the current gust speed, the current gust period, and the delta again, which is the target speed from the current speed divided by the period, so the per seconds change. We'll also add two components, which one is attack time and one is decay time. The attack time is how quick the gust comes in, and the decay time is how quickly, when we're closing, that the gust decays. We'll also add a couple of balls, which are detecting when the gust is on or when the squall is on. Also, we'll be declaring a float array to store our wind force scale. I'm not going to worry about the standard deviation because I'm going to do a simplification and just divide the force by 8 to give us the standard deviation, just to make life a little bit simpler here. And then finally we'll store the current wind force, so that's our Beaufort scale. And then we'll declare the enum, which we store the gust status, so we tell where the gust is within the way the program works. I've added one here. Previously we just had 4. I've added gust starting. So gust off is when nothing's happening. Gust waiting is when we're counting down to start a gust. Gust starting is the attack phase. Gust on is the steady state while the gust is going, and gust closing is closing it down. And we'll see how that works later on. And then we'll declare a gust status variable to store the status. So we'll have a private gust status, and I'm just calling it gust status, and we'll set that as default to off, because as we're starting we don't want any gusts. So in the start function, the first thing we'll do is we'll fill up the wind force scale variables or data. So this is exactly the same numbers that we used before. We'll declare a new float array and fill it with the variables that you can see there. We'll also call two functions, set low frequency wind speed and set high frequency wind speed. This is just to make sure that the variables are initialized and that nothing funny happens when you start the program. We'll see what's in these later on as they're used again at various points. Moving on to the update function, we'll declare a frame time float variable, which is our time.delta time. We'll be reusing this, so I've declared this up the front. Then the first thing we do is we check the wind speed component periods. So this is the low frequency period and the high frequency period. So what we do here is we take the low frequency current period and take away the frame time, so we're reducing the period. And then we check to see if this period has got to 0. If it has got to 0, then we'll reset the wind speed, the low frequency wind speed parameters, so we'll call the low frequency wind speed function again. And exactly the same with the high frequency. We'll decrement the current period. If it's reached below 0, then we'll reset the variables. Then we'll adjust the current wind speed for both the low frequency and high frequency components. So we plus equals the delta speed times the frame time. Remember, the delta here is calculated per second, so we need to multiply by frame time. Next we look at the gust status. So we create a switch function here. Because we're in the game thread, we're not so worried about performance and all of the nasties that we were in within the audio thread. So this is the place to put switch functions. So we'll look at the gust status. If it's off, what we do is we check to see if the gust on has been ticked. If it has, then we move the gust status to gust waiting and we set gust waiting. We'll see that in a minute. If we're in the waiting period, then we decrement the period that we're waiting. So this is the gust period. And if it's got to 0, then we start the gust. So we move to set gust starting and set the status to gust starting. Once we're in gust starting, what we're doing is we're decrementing the period over which the attack time occurs. So the period will basically be the attack time. And in that time, we'll be increasing the speed by the gust delta speed times the frame time. So we'll be gradually increasing the gust over the frames. Once we got to 0 on the current period, then we set the gust to on, which is effectively our steady state. And we'll set the gust status to gust on. So we'll reset the variables and we'll see that happening in a second, and then change the gust status. So next we'll look at the gust on. So when it's in gust on, we're just counting down to the end of the length of the gust. So the gust period will have been set previously. And once it's at the end, we'll move into the gust closing status. So we'll do set gust closing and change the status to set gust closing. At this point, the gust itself doesn't change in value. It's a constant amount. So effectively, as I say, this is the steady state. When we move into gust closing, obviously we're reducing the gust speed from the current value down to 0. So again, we'll have a period over which that happens, the decay time, and we'll have a delta that's been calculated, which is effectively the speed at which the current speed must be decremented. We'll see that in a minute. Once we're at the end of the period, what we do, we check to see if on gust is still on. If it still is on, then what we do, we change our status to gust waiting. We change the current speed down to 0 just in case it's slipped into minus, as it might do. And then we set gust waiting, so we recount the variables that we need for the waiting period. If the on gust has been switched off, so there's no more gust, we basically move to gust off. Now I forgot this, and I noticed it when I was doing the video, that you have to add gust current speed equals 0 here. If you don't, there is one of the decrements will have occurred. It will have gone once too often. So the current speed will have been decremented once too often, so it'll be a small negative value. So this will set it back to 0. It's not a big deal, but it's more accurate to do it this way. Then the final thing is I've left in a debug status so you can see what's going on. So it comes back and tells you what the gust status is and what the current gust speed is. And that's then printed out to the console. Finally, an update, what we do is we send our wind speed and resonance data to the plugin. So we add together the 3 components of the wind speed, the high frequency component, the low frequency component, and the gust component. I put a little check in here, so making sure the total wind speed doesn't go over 30 and doesn't go under 0.1. So what we do next at the bottom here, we see master mixer, which is our exposed version of the mixer. And within that, there's a function called set float. And within the brackets, you notice there's a text which is wind speed. There's a string wind speed. Now that's what we typed in earlier when we exposed the variable. And then we send the data, which is going to be our total wind speed divided by 30. Now, if you remember, our plugin receives data from 0 to 1 by default. So if we divide by 30, 30 meters per second will give us 1, and 0 meters per second will give us 0. So it should scale things properly. And then the second one is setting the resonance, so it's setting distant resonance, and that's just total wind speed times 0.02. Apologies for the bing. Next we'll move on to the set wind speed functions. The low frequency wind speed and the high frequency wind speed are very similar. First of all, we get a couple of random numbers. What we want to do is to create normal distribution random numbers, not just random numbers. So I use the Box-Muller algorithm, which I'll go through later. But this will return a pair of normally distributed random numbers. Next, we'll have and calculate a new wind speed period. So for our low frequency wind speed, we don't want it to be the same all of the time, but it'll be around about whatever the mean is, and usually I'll put about 10 seconds. So what we do here is we take the mean and we add the standard deviation times the first random number, and that will give us a nice normally distributed wind speed. And we check to see it's not too small. Make sure it's not less than 0.1. If it is, we'll set it at 0.1. And then we'll set our variable that we created to that new wind speed period. Now, obviously, I could have done that in one line, but I just wanted to explain what I was doing. Next, we need to calculate the target wind speed. We'll take, in a similar fashion, we'll take the mean amplitude and add it to the product of the standard deviation of the amplitude and our second random number, which is independent of the first one. We can then calculate our delta, which is basically the target wind speed that we just calculated less whatever the current wind speed is divided by the period. Now what this does is effectively it works out a per seconds change to the wind speed. So as the update is going through, it will change by the amount it needs to per frame. Now the high frequency wind speed is virtually the same. We're getting our random normal, we're calculating our period. Now the only difference here is that if you look one from bottom, our target wind speed here is calculated as mean amplitude plus the product of the standard deviation, the random number, and here we add 1 plus gust current speed times 0.1. Now what we're doing here is basically we're making the wind more spiky as the gust occurs. We do the 1 plus gust current speed because current speed could be 0, and in that case it would completely invalidate the second half of the equation. So we need to do 1 plus, and we need the 0.1 is just a factor to scale the wind speed properly. And then we calculate the delta exactly the same way. Next we look at our gust functions. So the first one is gust weighting. So remember the default is gust off. When it detects that we have switched the gust on, it goes to gust weighting, and gust weighting pulls out more of these normally distributed random numbers and calculates that the period over which the weight occurs. Now in this case what I've done is I've taken the gust mean period that we set by the slider and multiply that by 10. So that normally is the gust, the length of the gust, but this is the wait time of the gust, which will be longer. Obviously you could expose that 10 to make it a public variable. And then obviously we just add our standard deviation times the random number as we normally do to get a distribution. Now we check this period isn't less than 2. If we're waiting less than 2 seconds, it would sound a little bit odd. And we just set our current gust period to whatever our new gust period was and return. After that, we'll look at the set gust starting. Now this is the attack phase. So again, we pull our random numbers and we calculate our new gust period, which is based on the gust attack time. So what we're doing here is we take the gust attack time and then we randomize it a little bit by adding the standard deviation times the first random number. Now the first random number here is, or these normal distribution can be positive or negative. In fact, they will sit around 0, so they're equally likely to be positive or negative. The other thing is that unbounded, so potentially they can go to plus or minus infinity, although it's, well, virtually impossible. But it's always worth bounding them. So again, if the new gust period ends up being less than 0.1, then we don't want a gust less than 0.1 of a second, really. So that's what we do. The next line is just a debug line, so I could check what was going on. And again, we set our current period to the gust period we just calculated. Next, we do our target gust, exactly the same as what we were doing when we were setting the wind speed. This time it is the gust mean amplitude plus the standard deviation times the random number again, so giving us a variable target gust. And then our delta speed is the target gust minus the current gust speed, so it's moving from where it is divided by the period, so giving us a change per second. Now the current gust speed should be 0, but I'm just adding the minus there just in case something's gone wrong. Next we have our gust on function, or set gust on. Again, pulling our random number. We calculate our new gust period, which is exactly the same as what we've done before. There's a slight difference here that I've multiplied the standard deviation by the mean period. This is because on the slider, what I've done, I've made the slider go from 0 to 1. And to sort of normalise it, to make it more realistic, I've multiplied by the period in this case, so it gives us some sensible numbers. You probably shouldn't set this value above 0.3, otherwise it will probably give too much variation. But it's another way of actually including the standard deviation in a sort of more normalised manner. Next I've got a debug line, so I can see what's going on. Next we check to see if the squall's on. If the squall's on, we multiply the period by 5. You could expose this variable again. And then we do another check just to make sure the period's not less than 1. We want our gust on period to be more than 1, otherwise it would just sound rather strange. So what we do is we set our gust current period to what we've now calculated, and the final one is a debug. Remember here, this is steady state, so we're not changing the gust value, the amount of the wind speed that the gust is generating. We're just calculating the length of time the gust lasts. Finally, we have gust closing. And again, what we're doing here, this is our decay time. So our period is going to be the decay. I'm always going to be whatever the decay says. I'll actually set this to 2 seconds. And what we do then is we calculate our delta, the amount by which the speed will decrease, simply by the current speed that it's at divided by the gust current period that is basically the decay time. So that will mean that the gust will decay down to 0 in the gust decay time, in our case 2 seconds. Next we have our Box-Muller function. This returns 2 floats as a normal distribution. It's quite a popular algorithm. It's very simple, as you can see. What we do is we get 2 random numbers. Now normally you'll see people just get 2 random numbers, but what you have to do then is check that one of those isn't 0, because if you look below you're taking the log of that random number, and obviously log of 0 is undefined. So what I do is 1 minus the random number, which means I'll never get 0. I could get 1, which will give me a log of 0, so we don't get a problem. Now what that does, if the number that you're returning, you're taking the square root of -2 times the log of the random number. Because it's a random number that's below 1, it will always generate a negative number. So don't worry, you're not going to create minus square roots. And then you just multiply that by the sign times 2 pi of the second random number that you generated. And that's the first value. The second one is exactly the same, except you're multiplying by the cos of 2 pi, the second random number. So you can see that that's how two independent normal random generated numbers can be created relatively straightforwardly. Finally, we create some setters for sliders and tick boxes that we create in the UI. And what we basically do is create a public void function that accepts a float parameter, or below at the bottom you'll see bool parameters. And what we do is we will attach that to the UI later on. But all we're doing here is we're taking, say, the set mean wind speed period, and we'll take that in as a float value, and then we just make that value equal LFWS mean period. The only one that's slightly different is the set wind force. Now, although wind force is actually an integer, I don't think there's an integer way of passing data, so it actually passes in a float. So what we do, we force that to an integer. So we, in the set wind force, we take in our value, which is between 0 and 11, after I corrected it. And the low frequency wind speed mean amplitude is calculated from that. In fact, it is that value. And the standard deviation, it's the value taken from the wind force scale array for that value. And the amplitude standard deviation is simply the mean amplitude divided by 8. That's a slight simplification from when we did it previously. So back to Unity, we can now create our UI. And what I've done is I've created a canvas off of the main camera, which gives us our background. And then I've added a number of sliders, so 5 sliders and 2 tick boxes. As you can see, we've added those components on the left-hand side. When we have the slider actually, I've also added a text. So if you look at the wind force slider, I have to add the text separately, whereas on the gust on tick box, that's actually part of a label of the tick box. This isn't really a Unity tutorial, so I'm not going to go into great detail, but I will show you how to hook up the various components that we have. And as you can see, there's our 7 components. If we look at the wind force, the wind speed force component in a little bit more detail, what I did, I created a blank component and then added a text component and a slider component to it. As I say, they have to be done separately. The slider has various bits attached to it, but we're not going to use that too much. So looking at the wind force on the right hand side in the inspector, you can see we can set a minimum value and maximum value, and we can also tick the whole numbers, and then below that we tick a default value of 3, or we set a default value of 3 for the wind force. Below that, we now need to attach the slider to our script. So on the left-hand side, underneath runtime only, we'll drag in the wind script, or the wind speed script, into that, or the wind component. That will then, on the right-hand side, give us access to the functions that we created, the setters that we created earlier. So if you tick on the drop-down box on the right-hand side, you should now see that we have wind speed available. And actually within that, we've got the various functions that we created first. We created in the C# script. So in this case, we'll select set wind force. And this will pass the value whenever the slider is changed into our C# script. I'll quickly look at the gust on bool. As I said, in this instance, you can just add a toggle. Because the label there can be set to set the text that you want. In this case, I've said gust on. This is slightly different in that it accepts a bool rather than a float, but is essentially the same. As you can see in the inspector, we can now add the wind component, or the wind script, into the on value changed of the tick box, And on the right hand side, you'll see that I've already set it to windspeed.setOnGust. Now, if we go back to the mixer, there's just something I wanted to mention. We have the parameters here, and you can see the little arrow next to the wind speed and the DST resonance, showing that these are exposed parameters. But there is one thing that you should be aware of. If you ever want to change any of these parameters while you're running, then the thing to watch out for is that the script is overridden at that point. So if you attempt to edit these parameters while the game is running in Unity, then the script won't be calculating the wind speed anymore, and you'll have to change that manually. So be careful if you move into edit and play mode. Obviously, if you need to edit these for default values when the game starts or when the program starts, then you'll need to do this, but be aware that the script will no longer be generating values to push into the plugin. So I've tweaked the variables a little bit. Obviously, you can play with this as much as possible. Setting the wind speed and resonance to 0 by default is good because it doesn't cause a big jump when you start up the effect. I did notice that if this was set to anything else, that the first fraction of a second was a little bit weird. So now we'll test the game. I'll change the wind force and you can see what effect the gust has. As you'll notice, the wind speed is constantly varying just by a little bit, and when the gust goes on, it varies a little bit more, giving quite a realistic effect. Obviously, you can play with all these parameters I've set. You can expose more into the game, but this is, I think, the best way of implementing the plugin, where the plugin is just doing the DSP and the C# is doing the things that happen at frame level. So what's next? First, a quick update on where we are with the various engines. The latest from Unity is rather disappointing. I was hoping that DOTS audio and DSP graphs would appear, but unfortunately those projects have been shelved. Instead, all they're going to do is make some rather small cosmetic changes to the audio engine, just the way in which assets can be identified and various things. But the old, and I emphasize old, Unity audio engine doesn't look like it's going to change for a few years, which is unfortunate. Luckily, Unreal Engine, I think, has saved us. Unreal Engine 5 has now been fully released, which gives us Metasound, which is a wonderful tool for procedural audio. And that's really what I want to concentrate on in the future. Metasound is beta, but it's fairly stable now. The changes will be fairly minor, I think, going forwards, and most things should work going forwards. So what I want to do next is actually replicate the wind effect in Unreal Engine 5 Metasound and blueprints. Now, don't be scared if you think Unreal Engine is complex. I will be able to do this in one video. The workflow for audio in Unreal Engine is absolutely amazing, very, very fast, very, very simple, very audio related. And the nice thing is that the audio team within Epic are accessible. There are Facebook groups, Discord groups. So if you get stuck, you'll actually get advice from the experts, which is certainly a lot different. And they're very open, very honest. They'll tell you exactly where things are with Metasounds, where things don't work, where things do work, and how they're planning to change things in the future. So life is a lot easier. So basically, I'm moving all of my audio efforts from Unity and concentrating in Unreal Engine, as life is so much easier. The only downside, it's not too much of a downside, but really, if you're using Unreal Engine, it has to be on Windows. A Windows machine is far superior because the way in which it works with Visual Studio is much more efficient. It does work with Xcode, but there's far less support. Also, Unreal Engine doesn't work very well on a Mac, and an M1 Mac it certainly won't work well because it's all going through Rosetta. Doesn't support Metal, so the graphics run incredibly slow. On my old Mac, I was getting something like 10 frames a second, and that was with very little happening. And if I switch all, and I mean all, of the visuals off and have absolutely nothing in the background, and I can probably get it up to about 40 or 50 frames per second. So I've invested in a new PC. I now have to suffer Windows, so that's the only downside. But it does mean that Metasounds works, or sorry, Unreal Engine 5 works so much better. So we'll be replicating the wind effect, and then after that I'll develop more sound effects using UE5 Metasounds blueprints and a system called Quartz, which is their timing system. Basically, this gives you sample accurate timing moving from the game thread to the audio thread. So for music, you can seamlessly splice together samples, you can loop samples, you can create musical things. It understands music, it understands beats, it understands bars, and when something happens, it happens at the right time on the audio thread. This just doesn't happen in Unity. It's not something that by default happens, and you'd have to use middleware. So we can look at that. Also, I'll be developing nodes, specific nodes within Metasounds to expand Metasounds, as this is feasible, very feasible, not too difficult. It's just developing your own tiny little bits of DSP to add into the graph. I will return to Unity for one thing, because I promised to talk about it, and that is to add sound sources. The project we've just done adds the sound effect to the mixer, but it doesn't spatialize it at all. You can't add it to a sound source, you can't move it around, you can't attenuate it, you can't pan it properly from where you're standing. There is a way of doing it. There's another plugin which you'll have to write yourself. It's not something that's standard, although it's something that Unity have included in a demo. So I did borrow the code from their demo, but I've cut out just the bit that does this. And then I've developed a C#, very simple C# script, which can actually spatialize it, so it will pan it properly where it is, from where the listener is. It will do the reverb, it will do the attenuation correctly. It's all a bit of a fudge, to be honest, and it's not what you should be doing, I don't think. I think there's something Unity should be providing, but I will show you how you can get around it. But most of my efforts now will be with Unreal Engine, as what you get is so much superior and works on all platforms. It works perfectly on Android, which Unity sometimes doesn't. So hopefully join me for the next one. Even if you're a Unity person, just join me for the next video. It might take a couple of weeks because I haven't done this one yet. But just have a look to see the difference between Unreal Engine and Unity when it comes to audio nowadays. They are poles apart. They are absolutely poles apart. And I think you'll be encouraged to use Unreal Engine. It sounds like I'm advertising them, but I'm not. But it is actually quite exciting, and probably why I've been rushing the last few videos, because I really want to get onto this, as it's much more interesting, much faster, and you're not messing around with the detail anymore. The DSP's there. They have lots of DSP code. They have lots of nodes which do all sorts of things. And there'll be many things that you'll spring to mind that you think, oh, wow, I can do this. So hopefully you'll join me again. It'll be in a few weeks' time because, as I say, I've got to develop this one from scratch. I've done other things in UE5, but I haven't done Wind, so bear with me for a bit. Hope to see you there. Thanks. Bye.